I have a special offer. As far as what we're going to see today is it's not really anything new. As we talk about probability distributions, we're going to connect it to what we've actually already done, but we use some new vocabulary. As I was doing this, I thought there's some of you who may have not finished up all of the homeworks, so here's the offer. It'll be helpful if you finish up the past homeworks. So if you'll get to at least 80%, I'll give you the full 100%. Okay. If you already have 100%, or if you get to 100%, I'll give you an extra 5% extra credit on top of that. So is that okay? Okay. Anything in the past. Anything from the past. So anything you haven't got finished. Yeah. So get it. And there's a special offer on 3.4. Value. Okay. It's got ones I'd like you to try, but there's a lot in there. So get about 50%. Okay. And part of this is we have grade reports that go home pretty soon, right? Due next Tuesday. Progress report period ends this Friday. So you need to get it done quickly if you wanted to reflect on that. Okay, but we'll do that. Okay. With that being said, let's get a strong start into 4.1. And again, I'm going to show you if you remember what we did when we were doing frequency tables, that's all we're doing today. If you remember about weighted means, that's what we're doing today. Okay, so it's really the same thing, but we are throwing some additional vocabulary onto this. Okay, so you'll see some different words and we'll call it different names, but I'm hopefully make the connection that they're the same thing. Okay. So first we'll start off with something called a random variable. We use this word to represent a random variable. I studied, when I went back for my master's degree at graduate level, I was studying probability and statistics pretty heavily. I was going to go get a job working for an insurance company as an actuary. That's kind of what this comes from. And I remember this thing of random variable just didn't make any sense to me because I thought about it too much. What I want to do is get you so you don't think about it too much. What is a random variable? It's just a numerical value associated with each outcome of a probability distribution. So we've done some rolling dice, right? So if I asked you what's the probability of rolling a die and getting a 3, what would you tell me? 1 out of 6, 1/6, right? In terms of thinking of this as a random variable, what they do is they call each of these outcomes an x value. That's the random part of it. So x equals 1 as you roll a 1, x equals 2 as you roll a 2, x equals 3 as you roll a 3. So the notation gets a little different, but it's really the same concept. Probability of rolling a 3 is still 1/6, okay? Or 0.167, if you round it. The thing is we can use this concept for other things as well, such as a salesperson making calls. You could let X be the number of calls they make during a day. I used to be in insurance sales for, how long? I did that for 13 years. And sometimes I would get paid by how many phone calls I made. And so you just keep making phone calls. And if you're selling insurance, you make 100 calls and you're lucky if you get one person to listen to you. So, sales positions, they will pay. You can make a lot of money, but you have to also have sort of thick skin and just keep going. The other thing is sometimes I didn't like that one, but if I set for so many hours, I'd get paid by the hour. So we could let X be the number of hours a person makes those phone calls. Okay. And in those two, there's two different types of variables here, right? The one who's getting paid by the call, they've got what's called a discrete variable, a discrete random variable. Because can you make 2.5 calls? No. I started to call, but I hung up. No, that doesn't count. You either make a call or you don't. You make 2 calls or you make 3 calls, but you don't make 2.5, you don't make 2.25 calls. So discrete variables are that way. They're 1, 2, 3, 4, 5. Now they could also be negative values, but they are not these in between. We could go with like shoe size. So I guess it could be a half, but it's, you know, shoe sizes are 9, 9.5, 10. You don't have everything in between. So discrete are just specific values. And so this takes us back to like where we were talking about the 4 levels of measurement: ordinal, nominal, ratio, interval. You remember those? So it's along those lines. How about if I was making phone calls and paid by the hour? That's a continuous, because I could make 2.5. I could work for 2.5 hours, 2.25, 2.1 hours. So that's the idea of continuous, right? It could be anything in between. Good news is we're going to, the mathematics is different for each type of those variables. We're going to be starting with this week with discrete variables. So there'll be 1, 2, 3, 4, 5. The mathematics is a little bit easier to understand with discrete rather than continuous. And the mathematics is a little different. So we're going to start off with just discrete, but we want you to know there are 2 kinds. We'll get to the continuous, I think, next week sometime. So we want to be able to identify whether a variable is discrete or continuous. So here's an example. If X represents the number of Fortune 500 companies that lost money in the previous year, is this discrete or continuous? Discrete or continuous? X equals number of companies. Which one? Can you have 2.5 companies? Your company either made money or lost money or broke even, but you either lost money or you didn't lose money. Let's put it that way. So this one actually is a discrete. You know, you could have up to 500 companies that could have all lost money, but you don't get half of a company or a quarter of a company losing money. Okay, so this is so when it's number of things we're counting, that's always going to be discrete. How about this one? If X represents the number of volume of gasoline in a 21-gallon tank, is that going to be discrete or continuous? Continuous there, right? Because you can have 2.5 gallons, you can have 2.1 gallons. So yeah, so those are going to be continuous. You have everything in between. So generally, it's a sum of a measurement. It's going to be considered discrete. Sorry, continuous. Okay. So now we're going to make the connection between probability, which we were doing the last couple weeks, right? Stuff, and going back to frequency tables. Okay. So let's think of this. With probabilities, what's the largest probability you could have? 1 or 100%. However, if you want to think in percentages, 1 or 100% is the largest. What's the smallest? 0, right? Can't have negative probability. So that's one of the rules, is that probability values, each one has to be somewhere between 0 and 1. And for it to be a distribution, we have to list all the probabilities, so when we add them together, they have to add to what? How do we know we have a complete sample space? How do we know we have everything? The probabilities have to add to 1. Okay, so that's the idea. So each one has to be between 0 and 1, and if the multiple ones, they all have to add. Now, it can't be less than 1. If it's 95.95, we're missing something, right? If it's bigger, we got too much. So it has to be exactly 1. Occasionally, if we're doing some things, we get a little bit of a rounding error, maybe. So we might get 99.99. Okay, that's a rounding error, but that's different. So let's walk through an example, and I want you to see that we've already done this mathematically. What we're doing, we're just putting some new names on this stuff. So the example we're going to use is there was a test given to people to measure their traits as either being passive or aggressive. 1 to 5, 1 is extremely passive, 5 is extremely aggressive, 3 is in the middle if you're neither passive nor aggressive, okay? And these are the results of the 150 tests given. So what we want to do is we want to get a probability distribution from this. So how many total are there? 150. So if you add these frequencies together, you will get 150. Now, when we think of the term frequency, what does that mean? So like on a test, let's go with this one. So score of 2, a frequency of 33. What does the 33 mean? What does the number 33 in this context, what does that mean? $33 what? Employees answered, got a score of 2, right? That's what that means. 33 people out of the 150 said 2, or got a score of 2. That's what the frequency means. We also had 2 other kinds of frequencies that we had when we did a table. What were those two other frequencies? So it was an amount frequency. There's a relative frequency, which is a percentage. That's the one we're going to work. There's also the cumulative, which we're not going to use in this one. So what we're really doing here is just getting the relative frequency, or the percent. Instead of calling it a relative frequency, though, we call it a probability. Okay. So the way we calculate it is we take each of these numbers and we divide by the total. And while I'm doing this, if somebody wouldn't mind pulling out a calculator, because we're going to use them and hopefully learn how to apply some of the things we've done before, you could calculate these for us. I'll just write them. What's 24 divided by 150? I'm always in your way, aren't I? Most of the time. Sorry. I got a 0.16. 33 divided by 150. 22. 42 divided by 150. 0.28. 30 divided by 150. 2. And 21 divided by 150. 0.14. Okay. So we can look at them as each decimals, or we can look at them each as percentages, right? 16%, 22%. If we add all these together, what should we get? What do we get? 10, 20, carry the 2, 3, 4, 5, 6, 7, 8, 9, 10. We get 1.00, 100%. So we know it's a probability distribution because each of the individual values is between 0 and 1, and the total equals 1. Okay, we'll use this. A lot of times I'll write a probability distribution this way. It's all the various values we can achieve. Remember, those are the random variables, 1 through 5. Those are scores. The probabilities, the percentages are just random, not random, relative frequencies, right? Same thing we did, we just give them a little different name. And it's got the concept, though, if we randomly chose somebody, the probability of getting someone who scored 3 would be 28%. Okay, so that's the idea. So far, so good? Nothing really new, right? Cool. And this is a list. I left this in here. This is what we did. But they put it first, and so, give you the step. So if you like step-by-step, the slides in here, we made the distribution. We found the sum. We calculated the probabilities by getting relative frequencies, right? Dividing each one. And then we did a check. Each one's between 0 and 1, and they added to 1. Okay. So that's there to take a look at. Okay. Notice what we've got. We've got a probability distribution, which is just really a frequency chart with relative frequencies. We can plot it as a histogram. Here's our scores. We see it's kind of somewhat symmetric. What would you tell me about the mean, median, mode? What would the mode of this one be? The one that has the most value, score of 3. If I ask for the median, just from visually looking at that, what's the middle value? About a 3, right? And how about the mean? Just looking at this as being symmetric, what would you think the mean would be close to? How about 3? So the middle value is about 3. We're going to actually calculate it, and we'll see what we get pretty close. That's what, because once we get a probability distribution, that's one of the things we want, is we want to know its mean. Okay, but before we go too much further, let's see if we can remember what a probability distribution needs. Is this this is a new table going 0, 1, 2, 3. It's a probability of rain over a 3-day period. So it either rained for 0 days, 1 day, 2 days, or 3 days. Those are percentages. Is this a probability distribution? Yes or no? It looks like one, but how do we know if it is or not? What are the two things it has to, what are two tests it has to pass? Each one has to be what? Between 0 and 1. Is each one of the values between 0 and 1? Yes? No? Yes. Yes, it is. The second part is, what do they all have to add to? Do they add to 1? Looks like it. Close enough. They do. So if you add them all, they add to 1. So it is a probability distribution. Let's try it again. Here's another one. Is this a probability distribution? No? Why not? Each one is between 0 and 1, right? So past that one, but how about the second one? What does they total to? Add them all up. You get 1.07. So, you might just look at it, oh, it looks close enough, but no, it doesn't. It can't be close enough. It has to be exact. They don't add to 1. This is not a probability distribution. The good news is then we don't have to even worry about it. We don't do anything with this because it's not a probability distribution. That's the name of this section. We're not going to do anything with it. Okay. but we have to be able to identify when things are and are not. Okay, so that's a key part. All the probabilities have to add to 1. Can't be bigger, can't be smaller, have to be 1. Good. So now we're into the mathematics, and again, I'm going to show you, you know how to do all of this. So to get the mean of a probability distribution, we take each of the random variable values and we multiply them by their probability. So we're going to do this with this last one we did, and we're going to see how that works. I'm also going to show you how to use your TI calculators to do the same thing, just by entering it in as values. Okay, so by hand, what we would do is we would take the data we got, the distribution, remember these are the probabilities we calculated, and we would multiply them. So 1 times 16, I'm going to do it over here because I think I've got something that shows up over there. So I love to multiply by 1 because that's pretty easy to do. Figured that out when I was about 4 years old. Actually, my sister taught it to me, but I thought it was pretty smart because I knew how to multiply, at least by 1. Multiply by 2 is not as hard either. 2 times 0.22 should be 0.44. But I got stuck when I had to multiply by 3. So what's 3 times 0.28? Somebody help us with that. .84. Okay. 4 times 0.2 should be about 0.8. And 5 times 0.14, I think, is 0.7. And I just remember from last class. So now when we add these together, we will get the mean. Okay. And let's add these. This is 10, 14, carry the 1, 6, 14, 22, 29. Is that what you got? Now remember, before when we calculated the mean, if we had 5 numbers, we added them together and then we divided by 5. We didn't divide here, did we? But yes, we did. When did we divide? We divided when we calculated each of these numbers, right? So it's like we divided already. We don't, so the process is in this, we don't then divide. This is the mean. The mean is 2.94. Remember, each one of these are percentages. These are probabilities. We're multiplying by values, and so we're getting a weighted mean. What does this 2.94 mean in terms of this test? It means on average, the score was about 2.94, right? Or 3, right? And that's what we saw from the histogram. It looked like the middle value was about 3. And we've just sort of verified it here, 2.94. Okay, so they did it over there. Could have just done that. And then the mean. So we can do that to calculate the mean. What I want to do is I want to show you doing the same thing with your TI calculators. So if you've got your TI 84s or 83s, I encourage you to follow along, because if you need to learn how to go somewhere, what's the best way to be? In the driver's seat, not the passenger seat, right? Because then you got to learn. Okay. So what we're going to do, and again, we've already done this, but I want to do it in context of this. Let me clear out this. Okay, so we're going to go to our stat button. We're going to edit. That's where we put in our data. Oops, what if I've got stuff already in there? If I go to the title and I hit clear, and enter, it clears out the list. We're going to need both list 1 and list 2 cleared. So let's clear out your lists. Everyone ready to go? Kind of. It's being recorded, so you may be able to follow later on. But okay, so what are the values we put in here? We put these values, so 1 through 5. 1, 2, 3, enter, 4, enter, 5, enter. So those are my random variables, my x values, my scores, 1 through 5. In list 2, I'm going to put the probability that they happen, the percentages. And if I remember right, it was 0.16, 0.22, 0.28. Did I get? Okay, thank you. I'll cheat. Okay. 0.2 and then 0.14. Okay, so you've got, and so now you've got this nice table. You've just replicated it here, right? Now we can use the calculating tools from under stat. So once we've got it all entered, we go to stat, we go to calc. We're going to do one variable statistic. So these are not two variables. These are still one variable with their weighting, with their probability. Now, some of you have the more advanced version. You want your data to be L1. I'm going to leave it this way. So I'm going to go second. And notice L1 is on the 1 key. And I'm going to do comma, second L2. If you've got the more advanced, we'll just change the first list is L1, and then the frequency list is L2. And then you'll hit calculate. Okay, and I could do that in a minute if you'd like to see. And then you just hit enter, and look, right away it's done the calculation. We got that, didn't we? 2.94 for the mean, X bar. So we didn't have to do that. But the cool part is that we now also have the standard deviation, which is 1.27. We're going to walk through that calculation, and you're going to see that that is much more complicated. And so it's nice that we have a tool here where all we have to do is enter it in, and if we remember the steps to do the calculation, we're going to get our answers right here. Okay? We don't have to spend 2 pages worth of scratch paper and calculate 2 or 3 different times to make sure we got the right answer. It's going to be right here. Now, what's missing right here? What is this S of X? Remember that one? Sample standard deviation. Why is there no sample standard deviation? Because, remember, what's the difference between the sample standard deviation and a population standard deviation? In the calculation, it's what we divide by, right? Population, you divide by n. Sample, you divide by n minus 1. In this weighting, what is n? N is 1. What is 1 minus 1? If you divide by 0, what do you get? Infinity, or we usually say it's undefined, but that's why if there's no number there, you can't get a sample standard deviation. So for all the stuff we do here, all we have to worry about is the population standard deviation. Okay. But there's going to be questions on these, and that's you just got the mean and the samples, the population standard deviation. This is primarily what we're doing. Okay, and it's nice that we have a tool that will do it for us. We just have to practice using it. Okay. Okay. So now I'm just going to walk you through what we would have done. Remember, we know what the standard deviation is, but I'm going to walk you through that calculation so you understand what that number means. Remember, we got 1.27, right? The way that's calculated is that after you get the mean, which is almost 3, it was 2.94, you subtract it from each of the variables, each of the random variables in this case. We square it, multiply it by its weight. It's us the variance, which we don't use. We then take the square root, right, because we squared it and it unsquares it, and that's what the standard deviation is. But notice we're going to look at how much is involved in doing this calculation. Your calculator just did it seconds ago, and the thing is when you use the calculator, you're focused on what the number means more than if you spent 10 minutes trying to calculate it, right? The problem is you could easily lose track of what's going on. So let's go through the process. If we would start with this. We calculated its mean of 2.94. We would then take each of these x values, right, 1 through 5, subtract off the mean. This is a deviation. Remember, if we add these together, some are negative, some are positive. If you add them together, we always get what? 0, which is not very useful. So then we square everything. And again, this, if you weren't using the calculator, this is what we'd have to do. We get all these values. Then what do we do with those? We multiply those times the probabilities. And then we add them all together. And that gives us the variance. It's still not the number we need. We take the square root of this number. And we finally get to where we were already at with the calculator of 1.27. Okay. What I want you to understand about is what the standard deviation means. What we know now is it's got an average of about 3, a score of 3, with the spread is about 1.3 above and 1.3 below. So an average score of 3 with very usual scores being maybe 2 to 4, right? 1 below, 1 above. If we think of discrete probabilities. Does that make sense? Okay. It's not really anything new yet, is it, really? We've done this, but it's got some new vocabulary. And when you read the questions, you might think, I don't know, what are we doing here? Stuff we did before with just some new vocabulary labeled on there. And some things that we particularly look at. Okay. The other thing is, this is another new word we're going to use. Instead of just calling it the mean, because it's a probability, the mean is also the expected value. Okay, so once we've got the mean, that's the same thing as the expected value. Now that won't work for everything we do, but for this type of distribution, a probability distribution, a discrete probability distribution, once we have the mean, that's also our expected value. What the expected value is, it's what would happen if we did this a large number of times. Okay. So this is how insurance companies actually set the premiums that you pay for, like car insurance, life insurance, everything. How much are we going to have to pay out? What's the expected value? And we got to charge everybody else so we can at least break even, but actually they like to make profit too. So they add all that in there. So let's take a look at our last example, which is good. We'll still have time to get, so we're going to do an example together and see how this works. Okay, an expected value. So we go to a carnival and there's a raffle. There's 6,500 tickets. And here's the good news. There's 4 prizes, 500, 250, 150, and 75. You buy one ticket, you're a winner. You win one of those, right? Find the expected value. So what would be the average that could happen here? So what we're going to do is we're going to take this table, set this up as a probability distribution. So first of all, what are the random variables? Random variable is what your net winnings would be. So let's say They give you $500, but what did you have to do to get that ticket? You had to give them $2, right? So really, you only won $498, right? So what we're going to do is we're going to subtract the $2 fee, the $2 ticket price from each of these winnings and get the net winnings. So this is 248. This is 148. This is 73. And then if you didn't win anything, you lost $2. But it went to charity, right? So you're happy, you know, help the school, whatever. Okay, so those are the random variable possible values we could get. It's discrete, isn't it? You get either one of these values. What's the probability of being the one who won $498? How many people are going to win that prize? I think I heard it. Just one person out of 1,500. And again, I'm going to show you how to use your calculator, so you're going to see it again, that this calculation. Only one person is going to win this second prize. So that's a 1. The probability of winning is 1 out of 1,500. This one, only one person's going to win. This one, only one person's going to win. Now the last one, everybody else is a loser. They're going to lose the $2, except for that one. So this would be 1,496 people will lose the $2 out of 1,500. Okay. To get these totals, we would, if we were doing this by hand, we would multiply the value times the probability, right? And then we would add them all together. But some of these numbers are actually going to be very small. So what we're going to do is use our calculator again and enter this as a table. The x values being in list 1 and the probabilities being in list 2. Okay, so again, just some practice. We hit the stat button. We go to edit. We need to clear these other ones out, so I arrow up to the top, have list 2, I put clear, enter. I go over to the other list, go to the top, the title is there, clear, enter. Okay, so I've got 2 lists that are open now. I need to put these values in, 498, 248, 148, 3, and so I'm going to enter those, clear these, 498, enter, 248, enter, 148, enter, 73, enter, and -2. Now, your negative button is not your subtraction button. It's that one that has parentheses around it. It should be next to the decimal point. So -2 is put in like that. Okay. Otherwise, you'll get an error code because it's trying to subtract when it can't. Okay. What goes into list 2? The probabilities. Now, I'm not going to calculate them separately. I'm just going to enter this in as 1 divided by 1,500. Right? When I put enter, it calculates it for me. It's got a strange number, maybe you're thinking, 6.7 e to the -4. Remember that -4 is an exponent on the 10. It's a scientific notation, so I would move the decimal back to the left 4 places, so it's really 0.0006 something. I don't have to worry about that because I'm going to do this for each, right? So the next one, 1 divided by 1,500. 1 divided by, 1,500. 1 divided by 1,500. And the last one, though, is not 1. It was 1,496 divided by 1,500. And again, we get very weird numbers, or a lot of decimals and stuff, but we don't have to worry about this. It's all going to get taken care of What did we want? We want expected value. That's the mean. So we go to stat, over to calc, down to one variable. And remember, we put in list one and list two. List one, comma, list two. And when we hit enter, it's going to calculate the mean is a negative 1.35. Means on average, there's a loss of $1.35. So more people are going to lose than are going to win. Now, again, what it is no person will actually lose $1.35, right? There's a lot that will lose $2. There's some that will make money, but it averages out to this. What can happen is if you are the person who's running this program, you're the school or the what that means is that's a positive value for you. On average, you're going to make $1.35 off of each person who buys a ticket. So this is what like a casino uses. Yeah, we're going to pay some prize money, but in the end, we're going to make money. And I did this. If you take 1,500 times $1.35, they're going to make a little over $2,000 this event if they sell all their tickets. And again, they're giving a $500 prize, but that's what got people to buy the tickets, right? And a lot of times they do this, and companies have donated stuff, so sometimes it doesn't even cost them anything. But people will buy these tickets for these raffles. They win some good prizes. Some people, other people, they donate their money, and that's how money gets raised. Okay. Let's see. Let's come back here. Questions? Does that make sense? Okay, so this is how we would have had to calculate it. So these are in here. Those are your random variables. You subtract the $2 from each. You get the probability distribution. You could check this out. That does add the 1. It fits everything. You calculate it by taking each probability times the random variable. Again, if you get used to using your calculator, this is exactly what we were doing with weighted means. It's a weighted mean. And then when you're done, what that expected value means is, on average, a person will lose $1.35 for each ticket. From my point of view, expected value is not, you don't want to calculate that for the individual. It's really should be calculated for the company that's running it. Okay, because it's this law of large numbers we talked about before. You need a lot of stuff going on. So like for a casino, they use this. Insurance companies use this. How much are we going to have to pay out in losses of car accidents? And then they put all that together. So then they say, okay, we got to charge this much for each person. So we at least have that money to pay for it and make a profit. You know, with all this natural disaster stuff that has happened, the companies didn't know that they needed that much money. There are insurance companies losing money off of that because when the losses are greater than what they took in, the money's got to come from somewhere, right? But that's how insurance works. This is expected value. Okay. Average, something we've been doing. So I just want you to see a lot of stuff that we learn is simpler. It's just they put some additional vocabulary on it. And yes, it is a more powerful application. So, summary. What was my offer at the beginning of class about homework? Oh, you remember that one pretty good. Okay, so if you got 100%, you get a 5% extra credit. So a reward for being on track. And if you don't have it now, but you get it by the end of the week, you'll do that too. What was the other part of that? Right. So that's kind of to encourage those who maybe didn't get started. You don't have to get all the way, but I'll give you all the way as long as you get about 80%. Yeah. Yeah. Well, I appreciate you guys. You're working hard. Like I said, I'm used to teaching 150 students at once, and only 2 or 3 of them are paying attention. So if I get 5 or 6 of you paying attention, I feel like, wow, this is great. um, On 3.4, though, there was a special deal. What do you need on 3.4? 50%. Okay.